Hello everyone! My name is Connor Smiley, and in this video, I'll be showing off an analytical Raycaster as well as video game that I created in my second semester of university from January to April of 2018. So, the name of this video game is called Guns and Wands. It's a silly cartoonish video game in which two wizards fire orbs at each other until one takes critical damage. Since I wrote this demo when I was just learning how to program, the code is somewhat abysmal, yet the end result is considerably pleasing. So if you'd like a video going over the math behind raycasting, please check out my DDA Raycaster video. It's much more informative. However, let's still take a look at this demo for completeness sake. After clicking versus, the players load into the map in which they can hunt each other down and fire orbs at each other. So players have the option to shoot one of 5 orbs. You've got the water orb, fire orb, electric orb, and my personal favorite, the giant ice orb of doom, along with the basic attack for some spam. So once you seek the other player out, they've got different sprites depending on their angle. So right now I'm looking at the side of my enemy, but if I turn around to the front of them, the sprite changes accordingly, and they can see me as well. So I'm looking sideways, and now I'm facing them straight on. So that pretty much sums this game up visually. You know, the sprite scale based on distance, and we're simply sampling our ray textures based on some line intersection math. We've got a skybox that scrolls based on viewer orientation, and as well as a giant gray quad for our floor plane, finalizing our 3D effect. So let's deal some serious damage real quick and watch the player reset. And that's about all there is to it. Here's a different level that's somewhat more chaotic, but allows us to showcase some of the renderer's capabilities. So since this doesn't use a DDA and instead uses actual line intersections, we're allowed to represent our geometry with basically anything you can do with a line. For example, this is a black triangle right here, which would not be possible with a DDA-based Raycaster, since that forces you to have a tile map. Right here, we're looking at a lime green octagon, I think another white triangle right there, a pink triangle there. So again, whether it's convex, concave, it really doesn't matter. If it's a line, this thing can render it. To get a better idea of what I mean when I say all of our level geometry is represented by lines as opposed to tile maps, here's a bird's eye view of our level geometry. So for example, here's the pink triangle, and what we're rendering is the color of each ray based on the surface the rays are intersecting with. So now we can see some yellow for this surface, some red for the background, and as well a multitude of surfaces here. Here's that green octagon if we get up nice and close, and that just about does it.